Hey friends, so today we are going to cover another very important topic as far as quantitative aptitude is concerned, and you can find the questions from this topic, which is time and work, in almost all the competitive exams. So first we'll look at what type of questions are typically asked in this topic. So as you can see on the screen, these are some of the types of questions that can be asked in the time and work category. So the first question is, if a person takes 10 days to complete a work by working 5 hours a day, how many days he would take to complete the same work by working 8 hours a day? So this is one category of question. Second category of question is, if 50% working together completes a work in 20 days, how many days it will take 80 persons to complete the same work? And then we also have a category where we have cumulative work, like if A can do a job in 10 days and B can do the same job in 20 days, how much time they will take to complete the job when working together. So these are not all the types of questions that might be asked, but these are the generic type of questions, or the general categories of questions. We'll also discuss other types of question, another question, uh, the more advanced questions when we progress along this topic. So before going any further with this topic, there is very important uh, concept that we first understand. So there is a thing called time work equivalence, which is defined by the formula W equal to M into D into H, where W is the total work done, M is the total number of men or women working on the job or the persons working on the job, D is the number of days they take to complete that job, and H is the number of hours they are working per day to complete that job, right? So we also say this as MDH formula, which is man into day into hours is the total work that is done, right? So this is an important formula, and we can solve all the time and work related problems, if most of the time related and work related problems, if not all, using this formula. So we'll from this formula we can deduce lots of observations. For example, when we say that our W is M into D into H, if let's say uh, if my work is going to be constant, and if any of these are or all of these are varying, then I can say that M1 into D1 into H1 is equal to M2 into D2 into H2, right? So this is an important formula that can be used. So in the in it, few seconds ago we saw that a type of question in which it was asked that if 50% can do work in 10 days or 20 days, the question was, then in how many days 80% can do that work, right? So in that case the H1 and H2 was same, because it was not given explicitly that they are working more or less. So we can apply this formula and we get number of days as 50 into 20 by 80, right? Just 2 4 just 12.5. So it will take 12.5 days for 80 men to do that work, right? Similarly, if our work is not constant, so we can define W1 as M1 into D1 into H1. So you can see that the work is directly proportional to all of these entities, right? So if we increase the number of men by keeping D1 and D and H same, the work will increase. If we increase the number of days by keeping the men and R same, the work will again increase. And if we increase the number of hours that the men are working each day, then also the work will increase. So they are directly proportional to the work done. So we can also say that Since there is a direct proportionality between all these terms, we can also have this formula where our work is not the same. So work is differing, and we can say that the ratio in which the work will differ is the same as this, right? Because our W1 is this thing and W2 is this thing, right? So we can also put this formula to calculate the number of men or days or hour it will take if the work is changing. For example, if the question was that 50 men take a take 20 days to complete a work, then how many days it will take 80 men to complete the twice of that work, right? So in that case, our W is twice, and then we have this as our variable. So it will be 50 into 20 into 2 upon 80, which is D2, right? So this is 4, 2, and 25. So D2 is 25 days, right? So this time work equivalence concept can be applied in several scenarios where we can uh, observe whether W is being constant or W is varying. So another important concept is unit works, right? So what unit work is? So unit work is the amount of work that a person is doing in 1 unit of time. So if day is the unit of time, then that is the amount of work that they are doing in that particular unit of time. So for example, if A can do a job in A days, so capital A is the person's name and small a is the number of days that they take to complete that work, then he will do 1 upon A job in 1 day, right? Similarly, if B can do a job in B days, he will do 1 upon B job in 1 day. So these are the unit works done by A and B individually in 1 day. So if the question is how much time, let's say the question is, if we saw the third category of question wherein it was asked that if A can do a particular job in 10 days and B can do a particular job in 20 days, how in how many days they can do that job when working together, right? So we can approach it with unit works. So we can say that took A is doing 1 upon A job in 1 day and B is doing 1 upon B job in 1 day. So collectively they are doing 1 upon 1 plus 1 upon A plus 1 upon B job in 1 day, right? So they are doing uh, this particular number of work in 1 day. So the question is that in how many days they will do the entire work. So we can simplify this as this is AB and this is A plus B per day, right? So this is the amount of work they do per day. So if we simply apply unitary method, so this this amount of work is completed in 1 day. So 1 unit of work will be completed in 1 upon 1 plus B by AB, which is nothing but AB by A plus B days, right? So you can also memorize this formula, but I would suggest don't memorize it. You can just calculate the unit works and then you can apply that formula. So there can be more than 2% doing the job collectively, so it's better that you uh, process it with basic method, right? So in our question it was like, if A can do a job in 20 days, so in 1 day they will do 1 upon 20 unit of work, right? per day. Similarly, if B can do the work in 10 days, so B can do 1 upon 10 units of work per day. So in one day, A plus B can both do 1 upon 20 plus 1 upon 10 units of work, right? Which is 21 plus 2, which is 3 upon 20 units of work per day, right? So in how many days they will complete 1 unit of work? That is 20 upon 3 days. So this will be the answer for that question, right? So let's discuss few questions that are related to these concepts. So let's say a company undertakes to complete a work in 50 days with 50 laborers. After 40 days, the company realizes that only 50% of the work is done. So how many more men should be employed so that the work is completed on time, right? So the company, so we will first understand the question. So the company employed 50 laborers and they estimated that the work will be completed in 50 days. But he saw, or they saw, that in 40 days only 50% of the work was done. So if they don't employ any other more men, then the first thing is in how many days the work will be completed. So that will be 80 days, right? Because the half of the work was done in 40 days, so the complete work will be done in 80 days. So this is just intuitive. But since they have a contract, they have to complete the work in on time. So how much more men they have to employ, right? So again we can uh, apply the work time constancy or work time uh, equivalence here. So in this case, our W is going to be the same, right? Because 50% of work was completed in 40 days and another 50% is going to be completed in the next 10 days. So our work is going to be constant. So we can say M1 D1 H1 equal to M2 D2 H2. So our M was 50 men, D was 40 days, and R is going to be the same. So my how many men I have to employ to do the same amount of work in 10 days, right? So M2 will be 50 upon 40 by 10, which is 200 men. So 200 men will be required to complete the same amount of time that was done in 40 days in 10 days. So how many extra men that we have to hire? That is 150 men. So this you have to be very careful with, because the question asks that how many more men should be employed. So 150 more men should be employed for the next 10 days. Okay. So the next question is a slight variation of this. So they say that if let's say the contract was such that the schedule can go behind 10 days, it is not very strict contract, so it can go behind 10 days, so the company can complete the work in 60 days. So how many extra men should be employed in that case? So again our W is going to be the same, right? Because 50% is 50% of work is already done. So we have M1 into D1, which is 40, is equal to M2 into D2, and this time D2 is 20 because we have 60 days in hand. So that gives M2 as 50 into 40 by 20, which is 100. So 50 more men has to be employed, right? And that can also be seen like this. So in 40 days, 50 laborers were required to complete a work or to do a certain amount of work. So in half of that day, we will require the double of the number of laborers to do the same work, right? So that's why we need 100 men, because we only have half of the amount of days that were earlier required. are earlier taken. In the third question, it is again a slight variation in which says that, let's say, after 40 days they realize that only 20% of work is completed. Then in that case, how many men should be employed to complete that job in time? So now we don't have W as same, right? Because the first part of work is 20% and the second part of work is 80%. So we have W1 upon W2 is equal to M1 T1 H1 upon M2 T2 H2, which gives us W is 20%, this is 80%. So we have 50 into 40 days. So it 20% of work was done, right? So this is the uh, equation that we get. If we solve it for M2, it is 50 into 40 into 80 upon 10 into 20, right? Which is 20. This is 4, 10, 4. So this is 16. 16 into 5 is 80. So 800 men. So that means we will require 750 more men to complete the job in time if only 20% was done in 40 days. So this is how we can apply the simple formula, which is MDH formula, to tackle different type of questions. So the question is, if A, B and C can do a piece of work individually in 8, 12 and 15 days respectively, A and B start working together, but A quits after working for 2 days. After this, C joins B till the completion of the work. In how many days the work will be completed, right? So this is the question. So we'll break down this question and try to solve it with the concept of unit works and the individual work. So we know that A takes 8 days to complete that work. So they will do 1 by 8 amount of work per day, right? Similarly, B take 12 days. So B will take 1 upon 12 unit of B will do 1 upon 12 unit of work per day, and C takes 15 days. So C will do 1 upon 15 unit of work per day. So now A and B has started the work. So A plus B can do 1 upon 8 plus 1 upon 12 work per day, which is, so this 24, this is 3 plus 2, which is 5 upon 24 work unit of work per day. Now they work together for 2 days. So in 2 days they did 10 upon 24 work unit of work, right? Because 5 upon 24 was per day work, so 10 upon 24. Now here A left that job and C joined the job, right? So in 2 days this much work was completed. So how much work was left? So 1 minus 10 upon 24 work is still left, which is 14 upon 24. So this unit of work is still left, right? Now B and C together they do 1 upon 12 plus 1 upon 15 amount of work, which is 60. So they together do 9 upon 60 unit of work per day, and they have to do this amount of work. So how much time they will take to do this, right? So we know that W equal to M into D. So our W is given as 14 upon 24. Our work per day is uh, 9 upon 60. So we have to calculate the D, right? So D is 14 upon 24 into 60 upon 9, right? So this is, so if you divide this by 12, so this is 2, this is 5, which is 70 by 18 days. So this is the amount of time that B and C will take to complete the job. So in how many days the work will be completed? So 2 days when A and B were working together, and 70 by 80 days when B and C was working together, right? Which is 106 upon 18, right? So this is the number of days that it will take to complete that job. So we saw that using simple MDH formula and the unit work and individual work concept, we can tackle a variety of questions related to time and work. There are other types of questions that we are going to cover in the next video, like alternate work or negative work. So those are some advanced concepts, and we are going to cover them in the next video. Do like this video, subscribe the channel if you want to get notified for all those videos that we put on this particular playlist and channel. Thank you for your time.